So we have type 1. That's us, humans, and other large vertebrates. So type 1 is going to put lots of energy into nurturing the baby. And they are long-lived. We are long-lived. And we don't have lots of kids, like hundreds or thousands of kids. We have 1 or 2 kids, and same thing with the other large vertebrates, but they give lots of care and lots of nurturing, and they make sure the baby survives. That's type 1. So in species that invest much energy caring for young, have low death rates early in life, and most individuals they survive too long enough to reproduce. And then we have, so we fall into this category. Mostly all of our babies live now, at least with the technology and the medicine. So here the y-axis is showing number of survivors out of 1,000. And you see this curve is mostly stable, and maybe you get old. This is age, you get old, then you start dying. So we spend lots of energy, lots of effort, we put in a lot of time to make sure the babies survive, they live long enough to the adulthood, and they reproduce. Then we have type 2. Many birds and mammals fall into type 2. So even penguins were in type 2. The last one we went over. So type 2 species, they have approximately equal probability of dying at any age. And that's because of predation. They can get picked up at any age. So that's going to give you this line. Again, you have the number of survivors and the age here, but they can die at any age. They have equal probability of dying young. They have equal probability of dying old or as an adult. So that's type 2. I would say that penguins were a mix of type 1 and type 2. And then these species, they invest a little bit, and they put little energy raising the babies, and they have high death rates among offspring, and only few individuals survive to reproduce. That's type 2. And then we have type 3. Go back. Type 3 here, so I don't have a slide for that. So type 3 is going to reproduce very, very quickly. Type 3 is not very long-lived. Once they reach their reproductive age, they have to just find a mate, and they have to reproduce very quickly. In addition to that, they're going to make lots of kids, hundreds to thousands of kids, because most of these kids, most of the eggs are not going to survive. So they're going to make lots of eggs, like fruit flies. So fruit flies have a day or two, they just make like crazy, and they make lots of eggs for that. Same thing for fish. Fish also make a lot of kids, because not all of the eggs are going to survive. So they're basically trying to overwhelm the predator by producing a large number or laying lots of eggs. So some adults, so I want to show you an example. It says in New Zealand. So it's called cave glowworm. So this is in New Zealand. So you can go to this cave, and if you look up, it's like constellation stars. You can see all these glowworms there. So this glowworm, the larvae insect has a mouth. So let me see. So as a larvae insect, it has a mouth and digestive system. Can't find a picture of the, let me see. No. Apologize, guys. I can't find any pictures. So anyway, so this, as a baby, it has a, so it can create this, see, can create this silk, and then something can get stuck into this and they eat it. So as larvae, they can eat. As baby larvae, they have a mouth, but then they go through metamorphism. And then as an adult, they don't have a mouth. They don't have wings, no mouth, no wings. So once they come out of pupa, they just have to find a mate as soon as possible, and they have to mate. So adults are not long-lived. They have to reproduce very, very quickly. They don't even eat. So this is the one I'm talking about. As a larvae, they have a mouth, they have a digestive system, they eat. But as an adult, once they come out of pupa, they don't have a mouth, they don't have a digestive system. The only purpose is to reproduce. So they have very short time. So they have to find the mate as soon as possible, and then lay the eggs, and then that's what's gonna populate the cave next year. So that's the purpose. So that's type 3. That's type 3 here. So these examples are just showing you that, so that these plants make hundreds to thousands of seeds. So this would be type 3. This is showing lots of eggs. So the large fruits of the coconut tree, evidence of high investment in each offspring. And the bear, they can't have 1,000 or 100 babies. That's just not possible. So they have 1 or 2, just like us, and they put lots of care into that, into taking care of the baby and provide lots of nourishment. The numbers can change year to year depending on the season and the food availability, but each organism can fall into one of those curves, type 1, type 2, and type 3. Do you guys have any questions about these 3 types? Any questions, guys? You guys understand it? So birds, large mammals, and species with type 1 or type 2 survival curves are often equilibrium species, means the same amount is dying, whatever is living. So I have some questions for you guys. What type you guys think it is?